Hello, assalamu alaikum. I hope everyone is doing well. So today we will see lecture number 13 from the subject numerical methods, and today's topic is Gauss-Jordan method. In order to find the solutions of the system of linear equations, this is the last method which we have to do, and after this method we would complete unit number 1. What is Gauss-Jordan method? If we were already having the Gauss elimination or Gauss elimination with pivoting, why we need to have Gauss-Jordan method? Okay, Gauss-Jordan is the another method for solving the non-homogeneous linear equations. What is the difference between the Gauss elimination and Gauss-Jordan is that in Gauss elimination we converted the matrix into the upper triangular matrix, and then by applying the back substitution method we find the roots of the system of equations. But over here in Gauss-Jordan method, instead of converting the system into the upper triangular matrix, what we have to do is we have to convert this system into the diagonal matrix. That means only these elements we have to make all the other elements equal to 0, and by this we would eradicate step back substitution step from the Gauss-Jordan method. Okay, so what we have to do is we have to find the roots of the equations and we have to convert this system into the diagonal matrix. How we have to do that? Let us do that together. So the solution, the first thing is we will convert this into the augmented matrix. So it will be 2 minus 2, 5 and 13, 2, 3, 4 and 20, 3 minus 1, 3 and 10. Let this be R1, this be R2 and this be R3. Always remember, in this augmented matrix for the Gauss-Jordan, the first equation is always treated as the pivot equation. Okay, and this element is treated as the pivot element, A11 element. Okay, this is the pivot element. So see, step number 1, what we have to do. Step first, divide equation first, that is R1, by A11 element. A11 means this is A11, A12 like that, right? A11 means the first element of the equation. तो पहली इक्वेशन को हमें क्या करना है? पहला स्टेप है कि जो हमारी फर्स्ट इक्वेशन है उसको हमें पहले एलिमेंट से सारी इक्वेशन के एलिमेंट्स को डिवाइड करना है. सो स्टेप नंबर ए आफ्टर दिस, तो हमारा जो इक्वेशन है सिस्टम है वो क्या बनेगा? A11 element for this system is equal to 2. Okay, so 2 divided by 2 is equal to 1, minus 2 divided by 2 is equal to minus 1, 5 divided by 2 is equal to 2.5, and 13 divided by 2 is 6.5. Fine. Rest of the elements would remain as it is, 3 and 10. Fine. Then what we have to do is, okay, B. Now we have to eliminate x1 from equation number 2 and x1 from equation number 3 with respect to the first equation, as we did in the Gauss elimination method. So let me write it. Eliminate x1 from equation 2 and equation 3. And for that we have to apply the transformations. So on R2, the transformation which we have to apply is R2 minus A21 times R1. Here we don't have to divide it with the first element. The reason being is we have already divided the first whole equation with the first element. Okay, So this will be r2 minus 2 times r1. Similarly, on row third, the transformation which we have to apply is r3 minus a31 times r1. This will be r3 minus 3 times r1. So these are the two transformations which we have to apply in order to eliminate x1 from equation number 2 and from equation number 3. Let us see how we can make both the elements equal to 0. So first one, firstly we will we will apply transformations on row second. So the first element is 2 minus 2 times 1. 2 into 2 is this, so this is equal to 0. Second element, 3 minus 2 times minus 1, which is equal to 5. This is plus 4, 4 plus this is 5, okay. Third element is 4 minus 2 into 2.5, this is 4.5, this is 0.5, this is minus 1. Then we have 20 minus 2 into 6.5, which is equal to 2 6 12. This is 7. Okay. Similarly, we will do the same thing on equation number 3, that is 3 minus, by applying this transformation, 3 into 1, which is equal to 0 first. Second is minus 1 minus 3 into minus 1, which is equal to 2. Third one is 3 minus 3 into 2.5, which is equal to minus 4.5. And then we have 10 minus 3 into 6.5, which is equal to minus 9.5. Okay. Please check the calculations carefully. Maybe somewhere the calculations might be wrong, but anyway, I hope this is correct. So our new system will be like this. The first equation would remain as it is in the augmented matrix. Then we have 0, 5, minus 1 and 7. Then we have 0, 2, 4.5, but minus 9.5. Now step number second. Now we have to eliminate this element and this element with respect to the second equation. Okay, R2 and R3. Eliminate x2 from equation number first and third with respect to equation number second. Okay, so before that, what we have to do is we have to first divide the equation or divide equation second by a to 2 element. That means we have to divide the whole equation by 5. So the system would be like this. 1 minus 1, 2.5, 6.5. 0, 5 by 5 is 1. This will be minus 0.2. This will be 1.4. This will be 0, 2, minus 4.5. And this will be minus, only the second equation would get changed. Now apply this step on this. So R1, R2, R3. So we have to apply the transformation on R1 minus a to 2 times not A22, A12 times R2. So this will be R1 minus 1 into R2, which will be R1 plus R2. Similarly on R3, this will be R3 minus A13, not A12, A32 times R2, which will be R3 minus what is this 2 minus 2 times R2. So these are the two transformations which we have to apply on this. So let us see how we can change the elements. 1 plus 0 is equal to 1. Second element, minus 1 plus 1 is equal to 0. Third, 2.5 plus minus 0.2 is equal to 2.3. Then the fourth one is 6.5 plus 1.4, which is 7.9. Similarly on row third, this is on row first, on row third, the second transformation, this is this one. Okay, now this one, first element, 0 plus 0 is equal to 0. Then the second element, R3, is 2 minus 2 times 1, which is equal to 0. Third, minus 4.5 minus 2 times 2.5, sorry, 0.5, 0.2 into 0.2, but this will be minus 0.2. Okay, so the result would be minus 4.1. Fourth one, minus 9.5 minus 2 into 1.4, so 2.8, 2.8, so this will be 12.9, 10, 11, 12, so 12.3, and this will be minus. Okay, so after this the new system will be like this: 1, 0, 2.3, 7.9. Second will be as it is, 1 minus 0.2, 1.4. Third will be 0, 0 minus 4.00 minus 4.1 and 12.3, 12.3 minus. Now step number 3, divide A33, divide equation third by A33, that is by this element minus 4.1. So after dividing this equation with minus 4.1, what we are going to get is the new system of equation: 1, 0, 2.3, 7.9, 0, 1 minus 0.2, 1.4, 0, 0 would remain as it is. Minus 4.1 divided by minus 4.1 will be equal to 1. Minus 12.3 minus 4.1 will be equal to, divide by this will be equal to 3. So after that, what we have to do is second step. This is A. Eliminate x3 in equation number first and second with respect to equation number third. Okay, so the transformations which we have to apply is R1 will be R1 minus A13 times R3, which will be equal to R1 minus 2.3 times R3 and R2 पे जो हमें ट्रांसफॉर्मेशन अप्लाई करना है, that will be R2 minus A23 times R3 to minus, what is A23, it is minus 0.2 and minus, that is minus, so it will become 0.2 R3. Okay, so sorry, firstly we will take this one and change the elements. So 1 minus 2.3 into R3 का element is 0, this will be 0 and 1 minus 0 will be equal to 1. This is the first element. The second element second element is 0 minus 2.3 into R3 is 0, so the whole will be equal to 0. Third, 2.3 minus 2.3 R3 is 1, so 2.3 will be equal to a 0. Fourth, 7.9 minus 2.3 into 3, so this will be 6.9, this will be 1, is equal to 1. Okay. So now apply this transformation on row number second. So the first element is 0 plus 0.2 into 0, this will be equal to a 0. Second element is 1 plus 0.2 into R3 0, so this will be 0, 1, this is 1. Third element of R2 is minus 0.2 plus 0.2 into 1, so plus minus this will be equal to 0. R2 का element is 1.4 plus 0.2 into 3, which will be 3.3, there is 3.6, no 0.6, so for this will be 3. So this will be a 3. Okay, so now clearly our final system of equation will be 1 0 0 1 0 1 0 3 and 0 0 1 and 3. Okay. So this is how we converted the whole matrix into the upper triangular matrix. Therefore x3 is equal to, directly we can write x1 is equal to 1, x2 is equal to 3, x2 is equal to 3 नहीं है, x2 is equal to, this is not 3, this is actually equal to, this is 2, 6.04 plus this is 2, so this is over here, this is 2 is equal to 2 and x3 is equal to 3. So this is it. Thank you.